All right, hey guys. So apparently my network transfer rate is low, but we're gonna try our best to get through it. So we talked about last time simplifying radicals and exponents. Here we're going to be taking rational exponents, using some of the same concepts. If you would go ahead and turn on page 293, we're going to go ahead and get started. And we're going to also talk about the little compound interest bringing forth here, which is something you guys are going to want to know later on in life for certain. All right. So if you would look at example 1, it tells us that we're going to evaluate each exponential expression. So for number 1, it gives us 16 and 1/4. When it tells us to evaluate, what we want to do, this is our new index, the 4 here. So if you guys remember the 4 from last time, we're going to bring the 4 out. 16 goes inside the radical. And is there a number here that's going to give us 16? And when I talk about making 16, that means a number that goes 2 times 2 times 2 times 2. How many times do we do that? 4. So that's 4 and 4, which gives us 16. So what we did, we evaluated this exponential expression. Same concept for b. Even though it's a negative, we got 125 for 1/3. So we're looking at 3. That's going to be our index number. We're going to bring 125 inside a radical. Is there a number that's going to give us? So yeah, we can go 5 times 5 times 5 gives us 125, but what was it? It was negative. So -5 would be our answer. What about C? C gives us a -9 to 1/2. Alright, here's the difference in this one. Alright. If you look before, 129, we were dealing with cubed root. Here, I don't know why my voice is leaving. I apologize. So we have -9. This unfortunately is going to bring out because it's a square, and you guys remember when we did squares in the bringing in those sweet i's. I squared was what? -1, which we had imaginary numbers. Guess what? Here they are again. So, since we have the square root of a -9, that is going to be 3i. Alright, because when we're dealing with our understood 2, unfortunately, we can't escape the imaginary numbers. It's like they just come back to haunt us again for some reason. Alright, so if we'll look at rational exponents here, we're going to talk about, and you guys can look at the list on page 293. It'll tell you your properties. You're going to want to know your product, your quotient, your power, and these are things we've been talking about. Power, quotient, zero exponent. So you kind of familiarize yourself on page 293 with the diagram of your properties of exponents. Alright, so with that being said, let's try example 2. Example 2 tells us that we're going to evaluate 4 and, let's see, we got 4 and 3/2. Alright, so this one's going to be a little different because we're doing rational exponents, and it says if the nth root of x is real and m is an integer, then we're going to set up like this. We got m, which we're going to bring 4. 4 is going to now be inside, 4 is going to be inside our radical. What are we bringing for our index? Same as before, we got 2. But what about the 3? See, before we had what? We were dealing with 1s. Here we have a 3. So 3 is going to become our exponent. Technically, it was before, like right here, but if it was just 1. So, right here, it was just 1, as opposed to having anything like a 4, 5, or 6, or anything above 1, if you will. So if we go back and look, we got 2. Now we need to figure out what's 4 times 4 times 4. Well, 16 times 3 is what? It's going to be 64. So is there a perfect square to 64 that you guys know of? I think I know of one. 8. Because 8 times 8 gives us 64. So guess what? 8 is your answer. So just make sure that you remember your denominator is your index, your whole number is going to be your radical, and your numerator is going to be your exponent. All right, flip on over to 294. Here we're going to be bringing out we're doing conversions. So we're already given our setup, if you will. So we got 4, 75, a to the third, b to the first. All right, we need to make what this time? Since we already have it, we kind of have to do it in reverse order, if you will. This time we need to figure out how we can come up with a fraction. Well, our index is, since there's nothing really given to us, if you will, we got to come up with our own. So let's just we know this everything's going to be over 4 because we bring it out. It's going to be what? We need to factor this out too. Also, what's going to be 75? Can anybody figure that out real quick? Well, I know we'd have 3, and a perfect square would be what? 5 to the second, because 25 times 3 gives us what? Gives us 75. So, with that being said, let's see if we can figure some of this out. So the A is going to be next. So it'll be a to the third, b to the first. And this is 3 to the first. So guess what? All these numbers are going to be over this. Okay, over our 4. So what I'm saying is when you rewrite it, you need to be 3 to the 1/4. 5. Now here's the thing. It's going to be over the 2/4 because you're going to bring whatever exponent. Or you can go ahead and reduce it. That's fine. It'll be 1/2. This is going to be 3 over 4. So a to the 3/4. And then we're going to have b to the 1/4. And that's all it's asking us to do. We brought our index. So all we did just then was the exact thing we did previously, except in reverse order. All right. Let's go ahead and try example 4 here. This time it says for us to simplify. So we're going to take, we're given 36a to the 6, b to the 12. Sorry, there must be somebody at the house because the dog's going crazy. What do we have different this time? We actually have a dun dun dun. This is going to be a decimal. Well, we know what 1.5 is as a decimal, do we not? It's going to be 1/2. So we're going to take everything and put that over what? Probably safe to say it's going to be over, at least over 2. We're going to take everything like we did previously right here and factor it back down. So we need to figure out of 36. So 36 is going to be what? It's going to be 6. And is there anything attached to, and I don't know why I said 1.5. It's actually 1.5 equals 3 over 2 as a fraction. So we need to go ahead. There was nothing attached. It's to the first. So it's actually going to be 6 to the 3/2. Now we're going to have b, which is attached to 12. So it's going to be 12 over, and we're probably going to want to reduce all these for sure. So we're going to have 6. That's going to be a to the, 3/2 a. B 3/2 times 12. So when we go to reduce all this, this is going to be, is it times 2? Yeah, because 6 squared. I forgot to put the 6 squared. That makes it 36, so I'm sorry about that. But on the bright side, we can go ahead and reduce this out. So that gives us, what's 6 times 3 times 3? Well, 6 to the 3rd power. 6 to the 3rd power gives us 216. So we got 216. Let's see. This reduces. That's 3. 3 and 3 is 1. So a to the first, remember if it's negative, not negative, if it's an odd exponent, then it's going to be an absolute value. And 3 to the, so 3 times 3 is going to be 9. And b is going to be, reduce that by 6. 3 times 6 is 18. So we should have 2 to the 8, I don't know why I put a to the first, so 216, a to the 9th, b to the 18th. So again, all I did is I took the 1.5, made it 3 halves. And other things that you guys have done, you guys have did the reducing a million times, you know, so that's, it's just getting the problem set up is the main portion. Alright, so let's take a look here at example 5. It says simplify each radical expression. Here we have 4. So we've got 1024. Now what we want to do here